Right triangle trigonometry. We've already looked at the 6 trigonometric functions when we were learning about the unit circle. So now we're just going to look at them again in the lens of a right triangle. And this tends to be the lens that students are most familiar with. We've all heard about opposite and adjacent and hypotenuse. So when we're dealing with the 6 trigonometric functions, it all has to do with the side opposite the theta, which is an acute angle, the side next to, which is the adjacent side, and of course the hypotenuse is always the hypotenuse. It's always across from the 90-degree angle. So now that we know which side is which, let's talk about how to define sine, cosine, tangent, and so forth. So sine is the opposite side divided by the hypotenuse. So if we know where theta is, we're just going to take the opposite side divided by the value of the hypotenuse, and that is the value of sine. Cosine is the adjacent side over the hypotenuse. And remember, tangent was just sine divided by cosine, which means it's opposite divided by hypotenuse divided by adjacent divided by hypotenuse, which means it's just the opposite divided by adjacent. So I didn't show you all of the math there, but I'm sure you can figure that out. Now, the other 3 trigonometric functions are, remember, just flipping over, or the reciprocals of these. So this is the hypotenuse, hypotenuse divided by opposite. This is the hypotenuse divided by adjacent. And this is the adjacent divided by the opposite. Let's take a look at an example. In this example, I've given you theta, not the measure of theta, but just theta. And I've given you the side opposite, which is 20, and I've given you the hypotenuse, which is 25, but I haven't given you the adjacent side. So before I can do any of my calculations, let's go ahead and find that missing side. We know that this is a right triangle, and so I can take leg squared plus leg squared is equal to the hypotenuse squared. So this gives me 400. 25 squared is 625. So a squared is 225. By taking the square root, a is 15. So the adjacent side is 15. So now I'm going to find all of my trigonometric functions. So for sine, remember that was opposite over hypotenuse. And then yes, I would go ahead and reduce that. So dividing by 5 gives me 4/5. Cosecant is just my result flipped upside down. So I don't need to put 25 over 20 and reduce. I've already reduced. Just flip it over, the answer for sine. For cosine, I'm looking at the adjacent divided by the hypotenuse. Again, dividing by 5 gives me 3/5. Secant would then be 5/3. And tangent is sine divided by cosine. So I could take 4/5 divided by 3/5, or I could take opposite over adjacent. Either one would give me 4/3, and cotangent would then be 3/4. I wanted to revisit the unit circle with you, this time dealing with degree measures, but we're really going to be doing the same thing. So keep in mind that sine theta is y. Secant theta is 1 divided by cosine theta, so it's 1 over x. Cosine of theta is x. Tangent theta is sine divided by cosine, so y divided by x. Cosecant of theta is 1 divided by sine of theta, so this is 1 divided by y. And cotangent theta is the reciprocal of tangent, so it's x divided by y. So now let's take a look at our questions. For our first one, we have 150. So for sine of 150 degrees, I'm going to get the y value, which is 1/2. For secant of 150 degrees, I'm going to do 1 divided by x. So this is 1 divided by negative radical 3 divided by 2, which would be negative 2 divided by radical 3. I have to rationalize that denominator, so it's negative 2 radical 3 divided by 3. Let's do the same for negative 45 degrees. So again, 45 degrees is here. That's pi over 4. We're looking at negative 45 degrees, or that's coterminal with 315 degrees. So cosine of negative 45 degrees is going to be the x value. The x value is radical 2 divided by 2. Tangent of negative 45 degrees is y divided by x, so it's negative radical 2 divided by 2 divided by radical 2 divided by 2, which is going to give me negative 1. And for the last, let's find yellow. I'm looking at cosecant, and I'm looking at 270, so 270 right here. I'm taking cosecant of 270, which is 1 divided by y, so 1 divided by negative 1, which is negative 1. And cotangent of 270 is x divided by y, so 0 divided by negative 1, which is 0. One thing to keep in mind or to note is that cofunctions of complementary angles are equal. So when we say complementary, we're saying two angles that add up to 90. So for instance, if I'm looking at sine of 30, sine is the y value. So sine of 30 is equal to cosine of the complement of 30. So the cosine of 60 is equal to 1/2 as well. And that's all we're saying here. So looking at the cosine of of pi over 4, which is radical 2 over 2, that's equal to the sine of pi over 4, because again, that's the complement. They're 45 degrees. And we could do that for all of them, but it's enough to know that sine and cosine are going to have the same value for complementary angles, tangent and cotangent, and cosecant and secant. I did want to throw in one question involving decimal degrees. So we can see that we're asked to evaluate cosecant of 34 degrees, 30 minutes, 36 seconds. And so it may be that you've never done a question like this before, and I've written out the work for you just as a good visual, but you can also use Desmos to do that. You're going to put 34, which is the number of degrees. You're going to add the number of minutes, 30 divided by 60, and then you're going to add the number of seconds, which in this case is 36. You're going to divide it by 60 squared. So I did put 3600, which is 60 squared, but that's how you're going to do it, is 60, because there's 60 minutes in an hour, and then 60 squared for seconds. So we get 34.51. Now I'm asked to find cosecant of that value, so 34.51, and I can do that just using my calculator. Trigonometric identities. This is a great reference of all of the trigonometric identities that we are going to use in this section. Now, we already know the reciprocal identities. We know that sine and cosecant are reciprocals, that cosine and secant are reciprocals, and that tangent and cotangent are reciprocals. So the first 6 identities are things you already know. We also know that tangent is sine divided by cosine, and cotangent is just the reciprocal of that, and therefore it's cosine divided by sine. So again, you already know those two. What you may or may not know is the Pythagorean identities, and I can't put enough stars next to this one for you to please write these down and remember these, because you're going to use these in this class, you're going to use them in calculus, calculus 2, other higher math courses, you should know the Pythagorean identities. So the first one is sine squared theta plus cosine squared theta is equal to 1. And keep in mind, any of these that we are learning, you can always manipulate algebraically. So I could say that sine squared theta is equal to 1 minus cosine squared theta, and so forth. And I could do that for any of the 3 Pythagorean identities. So the second one is 1 plus tangent squared theta is equal to secant squared theta. And the last is 1 plus cotangent squared theta is equal to cosecant squared theta. Let's take a look at our first applying trigonometric identities question. Now, I tried to include enough so that you get a feel for how to apply these identities, but not so many that you want to, reach through your computer and strangle me or anything. Now, what some students would do on this question is they would say, okay, well, if we have theta, we have cosine of theta is 0.96. So cosine is adjacent divided by hypotenuse. You might set it up like this and say, okay, let's go ahead and find sine of theta, which would be whatever we find for a divided by 1. So we would say 0.96 squared plus a squared is equal to 1 squared, which is 1, and then go from there. And guess what? That would give you the correct answer, but so would this. So a lot of times people don't see the relationship between the Pythagorean theorem and the first Pythagorean identity, which is sine squared theta plus cosine squared theta is equal to 1. Notice what we're going to do. Cosine squared theta is 0.96. We're going to square it. That's going to give us 0.9216. We're going to subtract that from each side, which would give us sine squared theta, or over here would give us a squared is equal to 0.0784. We're going to get the exact same thing. Take the square root to find that sine of theta is 0.28. So a equals, 0.28. Notice I'm going to get the same thing. Now the second one says find tangent of theta, and tangent of theta, if I were using my picture, tangent is opposite over adjacent, so 0.28 divided by 0.96, or tangent of theta is sine divided by cosine, which is 0.28 divided by 0.96. So hopefully it's all making those connections in your brain, and all I have to do is just simplify that to get about 0.29. Now these have to be my favorite. This is applying trigonometric identities to simplify, and you're going to use this all of the time when you start working through not just trig questions, but calculus questions dealing with trigonometric functions. So when we're trying to simplify, we're trying to just get it down to a simpler value. For instance, sine and cosecant. We know that those two are related. We know that cosecant is 1 divided by sine, or sine is 1 divided by cosecant. Either way I did that, I'm going to end up finding that I can cancel and end up with the value of 1. So whether I rewrote this as sine theta, and then cosecant is 1 divided by sine theta, and again, either way I would end up with just 1 as my solution. Let's look at tangent. Tangent is the same as sine divided by cosine. Cosecant is the same as 1 divided by sine. I can now cancel the sines and get 1 divided by cosine. But 1 divided by cosine isn't my final answer because 1 divided by cosine is the same as secant. So secant of theta would be as simplified as I could get this question. For my last question, I figured we'd throw in some foiling just for fun. So again, first, outside, inside, last. Now, because these are conjugates, one's plus, one's minus, that middle term's just going to go away. So all I have really, cosecant squared theta, and then minus 1. That is a Pythagorean identity. Cosecant squared theta is the same as 1 plus cotangent squared theta. And now I've got a couple of 1s, a positive and a negative, which means cotangent squared theta is my final solution. Applications involving right triangles. Let's take a look at an angle of elevation or depression question. So they're always going to give you these questions, and you're going to want to think about them in terms of a triangle. So we say we're standing 45 meters from the base of the Empire State Building. So this is you. You're beautiful. This is 45 meters. My very long line is the Empire State Building. I'm not going to try to draw a picture of that. You estimate the angle of elevation to the top of the 86th floor is 82 degrees. I'm not sure how you're doing that, but well done. The total height of the building is another 123 meters above the 86th floor. So this is to the 86th floor. And then we've got plus 123 meters above that, above the observatory. Okay. What's the approximate height of the building? So we're going to stop right there. That's question 1. What is the approximate height of the building? How are we going to determine this? Well, we have a degree. We're trying to find this value, and we know this value. So what we have to do is we have to say, okay, we have an angle, and we have the opposite side that we're trying to find, and we have the adjacent side. Which of the trig functions equates opposite and adjacent? And that's tangent. So I'm going to take tangent of 82 degrees is equal to x divided by 45. So it's just using the definition for tangent, which is opposite over adjacent, plugging in what I know, and now I'm going to isolate that x and use my calculator to solve. Now remember, it says what's the height of the building? Well, it's 320.2 meters up to the 86th floor, plus another 123 meters to the top of the building. So the height of the building is 432.2 meters. The second question says, what is the distance between you and your friend on the 86th floor? So what is the distance? Well, the distance would be this guy right here. So you are here, and we're saying, what's this distance up to your friend who's up here? So now I still have 82 degrees. I don't have the opposite side. I don't need that opposite side. I need the adjacent side and the hypotenuse. Now you might say, why wouldn't I use the opposite side? Well, keep in mind that x value, I've had to do some rounding. So it's best not to use that unless you absolutely need to. So I'm going to use adjacent and hypotenuse, which is cosine. So cosine of 82 is equal to 45 divided by y. Multiply each side by y. Divide each side by cosine of 82. And we can see on the right hand side, I'll have 45 divided by cosine of 82, and on the left, I have y. And now I can just use my calculator to calculate 45 divided by cosine of 82, which is 323.3 meters. So that is about how far away your friend is from you. I do want to give you one practice to try on your own, and to be fair, we haven't gone through all of the things that you would need necessarily. We haven't put those together for you to solve it completely, but you might be able to do it anyway. I would like you to press pause, read through this question, try your best. When you're ready, press play to see how far you got on this question. So we have a lighthouse 200 yards from a bike path on the edge of a lake. So we've got some lake here. We've got, this is a bike path. So bike. And I've got some lighthouse. There's my light. I know, I'm a beautiful artist. So here's my lighthouse. So from the base, we've got 200 yards. And we have a walkway to the lighthouse, and that is 400 yards. And we're trying to find this acute angle between the bike path here and the walking path. So I can see, I can model this with a right triangle. And from theta, I have the opposite side and the hypotenuse. And opposite over hypotenuse is sine. So I have sine of theta is equal to 200 divided by 400, or 1/2. Now, I was guessing that you might get to this point and then stop. And if you did, that's okay, because we haven't talked about how to go in reverse. So we don't have a great way to go in reverse yet. You probably, you may or may not know it. But for now, let's just go back to our trusty old unit circle. Remember, sine is the y value. Where is sine equal to 1/2? It's right here at 30 degrees, or pi over 6. And so that's my solution, is 30 degrees. Now, yes, there is a better way to do that on your calculator. We haven't gotten to that point yet, so for now, we're just going to use the unit circle. Up next, we're going to look at section 4.4, trigonometric functions of any angle.